Let's look at a couple examples of integrating, where my integral is given in polar coordinates. So again, just to remind you, we made the substitution, x is our cosine theta. We said y was our sine theta. And we found the Jacobian, which was the determinant of the matrix del x, del r, del x, del theta, del y, del r, del y, del theta. And according to our substitution, that was just cosine of theta, determinant of the matrix cosine of theta, minus r sine theta, sine of theta, and r cosine of theta. When we found the determinant, we got r cosine squared theta plus r sine squared theta, and that's just r. So that is this r here, the Jacobian. So let's just evaluate this integral. So just like when I have a double integral, I know I'm either going to integrate with respect to y first or with respect to x first. Here, I'm either going to integrate with respect to r first or with respect to theta first. So integrating with respect to r first, I will get 0 to pi. The integration of r, the antiderivative of r, is r squared over 2. I'm going to evaluate between 0 and 9 cosine theta. And then I'm going to integrate that with respect to theta. So that's integration 0 to pi. 9 cosine theta squared is 81 cosine squared of theta over 2. And the other term is just 0, so this is going to be my integration. I'm going to pull out my constant, 81 over 2. I'm integrating between 0 and pi, and I don't know an antiderivative for cosine squared of theta, so I'm going to use double angle formula to rewrite this as cosine of 2 theta plus 1 all over 2 d theta. So I now have 81 over 4 is my constant, and integration 0 to pi of cosine of 2 theta plus 1 d theta. And so I get 81 over 4. Antiderivative of cosine of 2 theta is sine of 2 theta over 2. Antiderivative of 1 is theta. And I'm going to evaluate at 0 and pi. Well, when I plug in pi into sine of 2 theta, I get sine of 2 pi. I know that's 0. I also know that sine of 0 is 0. So this first term isn't contributing anything to the value of my integration. So it's just 81 over 4 times pi, which comes from the theta. So 81 pi over 4. Let's do one more. I have integration 0 to pi over 6, integration 0 to 4, r squared sine theta cosine theta dr d theta. Again, I'm integrating first with respect to r, so I'm going to treat any term of theta as a constant. So this is going to be equal to integration 0 to pi over 6, r cubed over 3, which is the antiderivative of r squared. Sine theta cosine theta is a constant. I'm going to evaluate between 0 and 4, and then I'm going to integrate with respect to theta. So 4 cubed is 64. I have 64 over 3 sine theta cosine theta minus 0, so I'll leave that out. And I want to integrate with respect to theta. So again, I can use my double angle, half angle, but instead, I see a nice u substitution. So what if I let u equal sine theta? Then du is cosine theta d theta. And my theta bounds were 0 and pi over 6. So if u is sine of theta, I know that sine of 0 is 0, and sine of pi over 6 is 1/2. So I can rewrite this integration as integration 0 to 1/2. Pull out my constant 64 over 3. Sine of theta is u, and cosine of theta d theta is du. So I have 64 over 3, u squared over 2, between 0 and 1/2, which is 64 over 3 times 1/8. 8 and 8 cancel, so I get 8 over 3. And that's the value of the integration.